All right, here's example 4.5 from PreCalculus OpenStax. I wanted to do this example because, well, your book gives you a beautiful, elegant, completely correct solution here. I maintain there's an easier way to solve this equation here. So I'm going to show you a different way to do this, which I think is significantly easier than this method they go through here. Maybe significantly is a bit of an exaggeration, but easier. So what I'm going to do, I'm going to start out doing it exactly the way the book does it. I'm going to say, okay, I know that my answer is going to be equal to y equals ab to the x power, because I'm told this is an exponential function, and this right here is what exponential functions look like. And really what I got to do is figure out what a and b are equal to. And the way I'm going to do that is I'm going to use these 2 points right here. I'm going to say, well, if x is equal to -2, y must be equal to 6. So 6 must be equal to a times b to the -2 power. And similarly, using this point over here, 1 must be equal to a times b squared. Right, that's from this point here. Then this is where I depart from your book. Instead of solving for one of the two equations and kind of substituting back in, I think it's easier to divide the equations. So this is a little trick that will always work. This isn't specific to this problem. This will work on any of these exponential problems where you're given 2 points and you need to solve for the parameters a and b. So you divide them. You say if this equals this and this equals this, then this divided by this equals this divided by this. Or you could take it, you can go in the other direction. You say this divided by this equals this divided by this. And that's what I'm going to do. I'm going to say 1 divided by 6 must be equal to ab squared divided by ab to the -2. Why did I do that? Well, it turns out that I'll show you why I did this. For now, let's just go with it. So what's so great about dividing instead of what your book did here? Well, really the nice thing that happens in all of these problems is I'm always going to have an a in the numerator and the denominator. So I will always be able to cancel out these a's and say that 1/6 is equal to b to the second power over b to the -2nd power. But I will also always be able to combine these guys. Because I have the same base, I will always have the same base. I can just subtract the exponents. 2 minus -2 is 4. So I could really go from here, probably straight over here, and say 1/6 is equal to b to the 4th power. This is why I decided to divide them in the order that I did. I didn't want this to end up being b to the -4th power. Had you divided them the other way, you'd get 6 equals b to the -4th power, and you'd have one extra step. Not a big deal, but I prefer to have this exponent stay positive, and to keep this positive, I have to take the larger of the two exponents and put it up on the top. Anyways, you get to here, you know that 1/6 equals b to the 4th, so you take the 4th root of both sides of the equation, and you get that b is equal to the 4th root of 1/6. And note that you should put in a plus or minus here anytime you take the 4th root, any even root of both sides of an equation, but you don't have to because b has to be a positive number, not equal to 1. So this is my value for b. And once you know your value for b, you can solve for the value of a. You can use either of these two equations to solve for the value of a. This one looks a little bit easier to me. I can now grab this equation and say, okay, 1 is equal to a times b squared. So 1 is equal to a times, well, the 4th root of something. Let me write this. This is probably more steps than you have to show, but it might help make things make sense. If you're raising something to a fractional exponent, the numerator becomes the power and the denominator becomes the root. So likewise, if I have a base that has a root and an exponent, I can rewrite that as a fraction. But this fraction simplifies. 2/4 is the same as 1/2. So really what I get is that 1 is equal to a times the square root of 1/6. The square root of 1/6 is equal to the square root of 1. Whoops. The square root of 1/6 is equal to the square root of 1 divided by the square root of 6. So if I multiply both sides of the equation by the square root of 6, I get a equals root 6 here. And this will be the same answer your book got. It looks like it uses decimal places, which I'm not too fond of, but whatever. So what I would say for my final answer is y is equal to root 6 times, and then b, which I figured out was the 4th root of 1/6 raised up to the x power. This to me would be a even better answer than what they have here. I don't know if the directions asked you to round. It didn't look like they did. So this is an approximate answer. Here's an exact answer. But really the moral of this is less about the exact answer and more about this dividing by trick. Even if that didn't make sense to you the first time you listened through this, I recommend you watch that a few times and practice that trick. Because I promise you, this trick is easier than this substitution method. Probably worth learning.